In this video, we're going to be talking about what it means for two shapes to be similar. So let's get into that definition. Figures are said to be similar if the following two things are true. Corresponding angles have to be congruent. So corresponding means they're in the same spot. So if I look at this top left angle in this shape and the top left angle in this shape, they correspond. If they are congruent, then corresponding angles are congruent. Also, corresponding sides have to be proportional. What does that mean? Well, that means that these shapes are going to be a different size, but their side lengths should be in proportion, or they should be equal ratios compared to each other. So if I compare the top left here to the top left over here, that would be a 5:10 ratio. And if I compare the top right over here to the top right over here, that's a 2:4 ratio. Are those equal ratios? Well, a 5:10 reduces to a 1:2, as does a 2:4 ratio. So they are equal ratios. We would say that those two side lengths are in proportion. We do have to check every side length, and that's what we'll practice in these examples. So most easily similar shapes are the same type of shape, but different sizes. We just have to be more specific when we say they're a different size. They have to be proportional. So let's practice that. So in the following shapes, we're going to try and prove that they are similar or say that they're not. So we're comparing corresponding parts. I'm going to start by comparing the two left sides of this shape. So I'm going to set up a ratio saying 5:10 and then work my way around the shape. We got to compare all of the sides. So let's compare the tops and set up a ratio equal to 12:24. Compare the right sides, that would be a 10:20. And then the bottoms, that would be a 13:26. So make sure that these are all equal ratios. Reduce if you need to compare, or maybe you can visualize it in your head. But a 5:10 is going to reduce to a 1:2, as is 12:24, 10:20, and 13:26. They're all a 1:2 ratio. So because they're all equal, these shapes are said to be proportional, and they are similar. Let's look at this second example here. So again, working around the shape, comparing corresponding sides. I got a 28:35. I have a 28:35. If you have a ratio that repeats the exact same values, you don't need to write it twice, although you can. And then the last side would be an 8:5 ratio. So 28:35 is not the same as 8:5. So these shapes are not similar, even though they look like they're the same type of shape. Their side lengths are not in proportion. Here's another example. So let's start by comparing the left or the right sides. They're the same ratio, 9:54. I'm going to work the other way and do the bottoms next, 5:30. Now you can compare your ratios as you go. That might save you some time. If you can find two side lengths that are not in proportion before you're done, you can just cut to the answer. They're not similar. But let's work on all of them here. So I'm going to compare the last tops. The 12:24 ratio is the last thing I need to compare. Well, 9:54 can reduce to a 1:6. 5:30 can also reduce to a 1:6 ratio. But 12:84 is not a 1:6 ratio. So that's not equal. They are not in proportion. They're not similar figures. And one more time, we can do this triangle. 9:27, same as the right side, 9:27. And the bottom is a 4:12. By simplifying these ratios, I get a 1:3. And that's the same. 4:12 is 1:3 as well. So similar triangles there at the bottom. So that's for any type of shape. All types of shapes, if they're similar, their corresponding angles are congruent and their side lengths are in proportion. If we're just dealing with triangles, there are some shortcuts we can take. If I know I'm talking about two types of triangles and I want to know if they're similar, we can actually just compare two corresponding angles. If I know that two corresponding angles are congruent, that's enough to say that they are similar triangles. And the reason why is because this third angle is going to be the same if two of the angles are already the same. And if the angles are the same, then the side lengths have got to be in proportion. So there's a shortcut you can take if you know that two corresponding angles are congruent. Just say which two are congruent and corresponding, and you can call it the angle-angle similarity, and you can say they're similar. For a second type of similarity test, we could look at just two sides. We don't need all three sides. If we can find two corresponding sides that are proportional, and we can determine that the angle in between those two sides is congruent, then that's enough to say this similarity test. It's called the side angle side similarity test. Notice how the angle is in between the two sides in its name, matching the actual physical diagram of the triangles. So if we can say that 12 compared to 8 is the same as 24 compared to 16, then we know their side lengths are in proportion. We know that the two corresponding angles are the exact same, and that fits our side angle side similarity test. The last thing we can do is the same thing we would do for any type of figure. Just compare all of the sides and make sure all of the sides are in proportion, making the shapes similar. So because they're triangles, we just have to make 3 comparisons or 3 ratios. Make sure that those ratios are in fact equal, and then you know without having to compare the angles that the triangles are similar. So let's practice that. Let's see a couple examples here. We're going to use a similarity symbol when we say that two shapes are similar, and we're going to make sure that when we name the similar shapes that all of their pieces are written in the same corresponding order in the name. So when we name the two triangles that are similar, we're going to make sure that each of their pieces are corresponding and written in the same order when we say their similarity statement. All right, looking at this first example, we know that X and P, those two angles are congruent. So if I can find another pair of angles that are congruent, we can use that angle-angle similarity test. Well, I know that right here I have vertical angles, and vertical angles are always congruent. So if I name that angle PQZ and say it's congruent to its corresponding parts on the other triangle, XQG, we know that we have these two angles congruent. We have angles X and P congruent. We have two pairs of angles that are corresponding and congruent. We know these two triangles are similar based on the angle-angle similarity test. So to finish off the similarity statement, if I name the first triangle GQX, I got to make sure and name my second triangle so that corresponding parts are in the same order. What corresponds with G is Z, what corresponds with Q is Q, and what corresponds with P is X. Let's take a look at this second one. Well, I have two triangles. I got this smaller triangle, and I got this bigger triangle. Well, in both of them, angle S is the exact same angle. So I know that one of my angles is congruent. Unfortunately, we don't know the measurements of any other angles. So I can't use the angle-angle similarity test, but let's try and use the side angle side similarity test. So I got to make sure that two other sides are in proportion. Well, we can compare the left side of the small triangle to the length of the left side of the big triangle and set up a ratio comparing 19 to 57. And then I know enough to compare the bottom lengths. So I know the bottom length of the small triangle is 3, and the bottom length of the big triangle is 12, so I can set up a ratio saying 3 to 12. Now, if those are equal ratios, then I could use my side angle side similarity. But 19 to 57 is not an equal ratio as 3 to 12. So because they're not in proportional, the side lengths are not in proportion, we can't use this similarity test, and we don't know enough information to say that they are similar. So we're going to say they're not similar. One more time, just for fun. Let's do another one. This time we know 3 lengths, so let's set up and see if we can prove the side-side-side similarity. So if I compare the two left corresponding sides, I could say 12 to 3. Comparing the two right sides, I could say 76 to 19. And comparing the bottoms, I could say 76 to 19. Well, we don't need to repeat that ratio if we don't want to. Is 12 to 3 the same as 76 to 19? Well, this is a 4 to 1 relationship or ratio. So as long as 19 goes into 76 4 times, we're okay. And it does. So we can say that these two triangles are similar based on the side-side-side similarity test. And we can complete the similarity statement. So if I name the first triangle QKH, I just got to make sure and line up corresponding parts in the same order. What corresponds with Q is D, what corresponds with K is Y, and what corresponds with H is N. So I need to name that second triangle, triangle DYN, and I can complete the similarity statement.